Ideas for some classroom responsibility. So I want 2 things that are things we should do in class and 2 things that we shouldn't do in class. Rose?
We should be polite to each other.
Be polite to each other. I like that. So I'm just going to show that to be polite. Can anyone else give me a suggestion? Tuscany.
Keep the classroom tidy, don't throw pages around.
Okay. So to phrase that positively, we say keep the classroom tidy. Good,
Look after
love
the
it.
classroom.
Look after the classroom, even better. Alright. While I'm writing, can someone give me 2 ideas of things we should not do? Call out. Is that ironic? Rose.
Chew gum.
Chew gum. Okay, that's very specific, but I'll put it in.
It's just there was a student last week who kept chewing
Anyone
gum.
else? Something that we shouldn't do? Something that would be bad.
Yelling
again.
out.
Calling out?
Yeah.
Okay, cool.
No.
Calling out. Alright, so just in case you forget, these are things we want in our classroom. These are things we don't want in our classroom. Okay, just in case you get confused between the 2, now you know. So, today we're doing probability and statistics. So more specifically, I'm going to talk about probability trees. So, I've got a cauldron here, cauldron A and a cauldron B. So, these are my symbols. I've got blue, they're supposed to be frogs, blue frogs, black spiders. So these are my frogs, and these are my spiders. If I give everyone a frog and a spider, I'd like you to place one in either cauldron of your choice. So there you go. Spider, spider, spider. Frog, you have another spider. You have a frog. Come over this way. Yep, so just jump up, chuck one on the whiteboard, you can have 2 frogs. Stick one in the cauldron. Put it in the cauldron, in the potion. Oh, the magnets are not great on this board.
Oh, you need more flux.
Oh, it's expensive.
Nice, nicely done.
Cool, love it. I'm just going to put this one in the cauldron. Awesome. Alright, can anyone tell me, with your hand up, how many items have I got in this cauldron? Yes, 4. 4, perfect. So I have a total of 4. What about this one? Tuscany.
5.
Good job, 5. Alright, so I've written it like this because this is my total. So how many frogs are in this, Rose?
3.
3? Out of how many?
4.
Exactly. So here I would have 3 out of 4 frogs. Just as an example. I'm going to leave that for now. Now, if I'm talking about my tree, I want to know what are my probabilities of pulling something out of the first cauldron and then pulling something out of the second cauldron. So if I start off here, and I would say cauldron A, something happens, and then I pull something out of cauldron B. So just looking at A, how many options have I got? How many different things can I pull out? 2. Yep, no, your hand went up, it's all right. 2, exactly. So I either pull out a frog or spider. Nice. So, Anthony, can you tell me what is the probability, what is the likelihood that I pull a frog out? So I've got this many things. How many frogs?
3.
3 out of
4.
Perfect.
75%.
So that's even better. We're just doing fractions for now, but that's fantastic. Okay, Alex, spiders. What's my likelihood, probability?
You mean cauldron B?
Just still doing this one.
4 out of 1 out of 4.
1 out of 4. Nice. Okay, so these are my 2 options. From here, I'm now going to pull something out of cauldron B. So I've still got 2 options. I've either gone this way, and I'm still going to have 2 options, or I've gone this way, and I've still got 2 options. Is that okay? A few slightly confused faces. Now, what are my options? So Rose,
Yes.
I'm here.
Yes.
What are my options from cauldron B?
Either the frogs or the spiders again.
Exactly, still the same. So frogs, spiders. This one? Same. Frog, spiders. So now, sorry, I don't know your name. David. What is the probability of pulling a frog out right here from cauldron B?
2 out of 5.
Yep, sorry, frogs. Yep, you are correct. I'm going to move this. 2 out of 5. Rose, spiders?
3 out of 5.
3 out of 5. Tuscany, frogs?
is just true, isn't it? 2 out of 5.
2 out of 5, yeah.
So the same.
Exactly the same as above. Anthony, spiders? Anthony?
Yeah.
Spiders?
Spiders out of cauldron B would be 3 out of 5.
Ooh.
Is it?
I don't know what that is.
I think he's trying to speak German.
Your German threw me off.
Oh.
Alright, cool. So this is my probability tree. These are all the different possibilities that I could get. So now, if I gave you an example and I said, what is the probability, written P, of, let's say, 1 spider from cauldron A and 1 spider from B. So if I'm looking at my tree, if I want to pull a spider out of the first one, where am I going to go? This path or this path? Bottom path? Yep. Now if I want to pull a spider out of these two, top or bottom?
Bottom.
Bottom, exactly. Can I go this way and get 1 spider and 1 spider?
Yes.
Put your hand up if you think yes. Put your hand up if you think no. So the answer is no, because I want 1 spider and 1 spider. So here I've just got a frog. So straight away I've broken my condition.
Yeah.
So the circled ones are the only path I can take.
Oh.
So now this means that I've got the probability of spider and spider. That's how we write it. 1 spider and 1 spider. So what is this probability here, circled in blue? Someone? Rose?
1 over 4.
Yep, exactly. So 1 over 4. And second spider? James?
David.
David. Sorry, David.
You should 3 out of 5.
3 out of 5, exactly. So my total probability for this situation would be 1 on 4 times 3 on 5. So multiplication of fractions, can you tell me what it would be? What's the answer to this?
3
Oh, okay.
3 on 20, love it. Can we simplify? Anyone? Can it be simplified? To a whole number? No? Okay. So 3 on 20. So what this means is if I want 1 spider from the first one and 1 spider from the second one, if I did this 20 times, I pull something out, repeat 20 times, 3 of those times I should get 1 spider and 1 spider. Is that okay? How are we doing for time?
7:50.
Okay, alright, quickly. So, I timesed it here. Oh, sorry, is that a question?
What if I only pull it out do it 10 times? I can't pull it out 1.5 times.
That is true, that is true. So, we could just halve the number. You could have 1.5, which is fine, but in probability, we're always just going to round it. So, depending on which way you want to go, either 2 or 1.
Okay.
So, the reason we timesed it here is because originally I had 1/4. So if I draw my pie, I had 1/4. From that 1/4, I've then broken it into fifths. So I take my quarter and break it into 1, 2, 3 fifths. And I've got how many?
3.
3. 1, 2, 3. So that is 3/5 of the quarter, right? So if I write 3/5 of 1/4, can you remember this from algebra and maths? 3/5 of means
An overview of what we just saw between
times.
all our stages.
So 3/5 times 1/4. That's exactly what I did here, and that's how I got my total probability. All right, sweet.
I feel like I